Now let us start. You can just mute yourself. Okay. So since you know what is ETL and all, so that's fine. And so as you know what is ETL and what is ETL is doing, all of them we're aware of. But let us understand uh, some good things about facts and where we have to use ETL and all. So normally when the data is in MB size, okay. So this is where what we do is that probably you have thousands of rows, probably 10,000 rows, 20,000 rows. People are able to store the data and people are able to process the data, right? So we are able to store the data, we are able to process the data when you have little data. So this is where people are using Excel sheets, right? So end of the day, we are able to store the data in Excel sheet, we are able to process the data in the Excel sheet, and with the data sizes in MBs, probably you have, the data could be in thousands. So the point here, the data could be in thousands. I have 20,000 rows, I have 30,000 rows. So that is the meaning of 10,000 data. But slowly what has happened, the data is slowly going to, or turned out to be gigabytes. When, as you know, the gigabyte of size, when the data is getting generated, so probably lakhs of records or millions of records I can talk about. When the data is created like that, and we're using RDBMS concept or RDBMS tools to store the data. So this is where, as you said, you had worked on Oracle and you had worked on SQL Server, all of them, right? So this is where we were able to store the data and Oracle, SQL Server, DB2 from IBM, and we have MySQL from MySQL Corporation. Then we have Teradata from Teradata Corporation, like that. Okay. Now, we are able to store the data when you have lakhs of rows, but how do I process the data? Storing is being taken care by the RDBMS. Now, I wanted to process the data. So normally, if you have this kind of a data, people are processing this kind of a data using a C or C++ or Java. Or you can have PHP or you can have any .NET languages. So now, if you go to 10 years back and whatever we are creating the reports today, and whatever we are, using the data, we are dumping the data to somewhere, right? People are also having some kind of extra libraries were there. I'm able to get Excel data using Excel, using the SQL Server import export wizard. I should be able to dump all the data to the SQL Server. And 10-15 years back, the story was like that. So not much of ETL tools in the world, right? So, but how people were loading the data? When you give the data to the some data is there, and people are storing in SQL Server. Some kind of small tools were there; they were opening. But when the size is very little, so probably you have some 500 GB of data. So you have, say, some 100 GB of data. The number of rows could be in your database, say 10 million data, say 20 million data. It is in lakhs. So people are able to store the data in the RDBMS, then they're able to create some kind of a reports with the .NET libraries and Java libraries. So people are happy and creating a business intelligence application just like this. Okay, now what has happened today? Today the data turned out to be terabytes. The size of the data is terabytes of data. So when this data terabytes, for example, you're talking about crores of rows I'm talking about, and billions of rows getting accumulated in the business, then I wanted to store this data. So this is where, for storing the data, we have to use a concept called, data warehousing concepts. So data warehousing tools you have to use. And for the processing of the data, this is where you have to have your own cube and your own algorithms have to be there. Okay, for the processing of the data, normally what we do is that we can have data warehouse. So what can be a data warehouse? Data warehouse can be your SQL server or your Teradata, any RDBMS tool only. So you have to have here. So any RDBMS, so probably SQL server, Netezza, Microsoft, IBM Netezza is there. So we have a Netezza. It is a third-party tool, but purchased or bought by the IBM. So Netezza also very good tool to create data warehouses. And Teradata, anyhow, Oracle is the number one in RDBMS. They are there. And SQL Server also having 64-bit data center operating data centers with Windows servers and all of them. And the good thing is that SQL Server latest version, SQL Server 2016, can be installed in Linux. But previous years, last year also, there is no support to install SQL Server in Linux, but it is there now. So we can install one of these softwares, apart from MySQL, and you can have any RDBMS as a data warehouse. Only thing is that here you should be able to store lakhs of rows, and here you should be able to store. So these are known as OLTP, right? That's what I think probably you know about it. These are known as OLTP things, where you should be able to store your transactional data, and these have been created using a designing concept called, okay, so there is a front end, back end. The designing concept we have to use is ERD modeling, right? So you're able to store the data with the help of ERD modeling. You have master tables and you have a transactional tables. So that is how people used to have. So there is a master table, and here we have to call as transactional tables, okay? So that is the word we got. It is a transactional data. Transactional data means, day in, day out data, business data. So day-to-day data. So that is what we're talking about. So these kind of applications can support up to GBs of data. Here, these applications are designed using ERD modeling. These applications are more into OLTP applications, where you have more and more writing of data. So you will have data is there, but more and more you have current data or fresh data will be there in this. Okay, fresh data will be there, or you can have, this is what is called small size data. Probably in GBs you will be having data. And to design this kind of a databases, normally we use entity relationship diagram modeling. This is given by Dr. Peter Chen. Okay, he was the guru for this. He is the guru for this, and it is a small size data, probably this, and this data is known as the OLTP data, online transaction processing of the data. So, for example, whenever you book a something in your Amazon.com, so that is a fresh data. It is going to be captured by one one database. That is what is the transactional data. And small data, fresh data, and here we are going to use a concept called normalization. So this data, before that, this data is purely read and write data, but here more is writing, writing of data will be there. Okay? So here we are going to use a concept called normalization to remove the redundancy, and normalization is used to improve the writing capability. You have to be very clear. Writing. To improve the writing, normally people would use. So one table will be splitting into two tables. Two tables will be splitting into four tables. So when you have a primary key and foreign key relationship, and when you have the data redundancy has to be removed, and OLTP systems normally will have normalization. Normalization, because of the primary key and the foreign key, this kind of links, in OLTP systems will have more and more tables. So OLTP systems will have more and more tables. So everywhere you have small tables also, but primary key, foreign key links are more. Okay. So when you wanted to retrieve the data from the normalized tables from the OLTP databases, you have to make use of lots of joins. When you use joins, automatically what's going to happen? The reading capability will get decreased in these systems. Okay. So when you have lakhs of data, then you should be, that means when you have a minimal size of the data, and you should be able to store the data, and the writing capability is more and reading capability is less, even though the reading capability is reading is low here. So we are able to accommodate because the data is not read heavily. So 80% of the time you are only writing up the data. But when you come down to the data warehousing applications, so all the data from here, as you know, this data is dumped into the data warehousing applications here, as you said already. So here we have to have lots of historical data, right? That's what is the data warehouse we're talking about. So lots of historical data you're going to have, and after that you should be able to use lots of historical data. So here the data size be in crores. So large size of data. Large means what here? Large means definitely your data warehouse size should be in terabytes. So probably your data warehouse size would be some 20 terabytes or 100 terabytes, something like that. And here we are going to use a concept called purely read-only data, because historical data is going to be organized there. And here we are going to use a concept called denormalization. Why denormalization? Because denormalization improves, improves reading speed. So normalization improves writing speed, denormalization improves reading speed. Normalization will split one table into two, and denormalization will merge two tables into one, because you have to arrange the data in less number of tables. When you arrange the data in the less number of tables, you will have less joins. When you have less joins, what is going to happen is that whenever you join the data, so the speed is more, because you're joining 100 tables, you are joining 20 tables. Definitely you need not worry and table 1 dot primary key equals to table 2 dot foreign key. That kind of a headache is removed from the denormalization concept. When you have the data, more and more in the data, so definitely you should be able to store the data in the lesser number of tables. That is what is called as denormalization, and that same concept is known as a star schema. I think you would have known that. Okay, why star schema is faster? People will tell you in the data warehousing modeling. Why star schemas are, star schema is the fact table is directly linked to the star schema is directly linked to the fact table. So there is no dimension table is linked to another dimension table. If the dimension table is linking to a dimension table, according to the star schema, merge those those dimension tables and create a star schema. So denormalization concept will be star schema for you in the data warehousing technology. And normalization concept this would be your snowflake schema. Why snowflake schema? This is because one dimension table is talking to another dimension table. Okay. So now snowflake star schema is not part of OLTP, but only normalization means you have to understand snowflake schema. Only to write that point I had given. So let me remove this here. Let me write it also. Okay. So denormalization improves the reading capability, and here we are going to use star schema is more, but sometimes star schema is not available, then we have to use snowflake schema. Snowflake schema uses normalized concepts. So one dimension table is linked to another dimension table. So here the tables are more. When the tables are more, automatically the star schema will become a snowflake schema. Now denormalization improves this. So this is how the data warehousing is built: historical data, large data, read-only data, denormalized data, star schema in the data warehouse. Now how you will be going to design this? Here we are going to use a concept called dimension modeling, right? So this is what you have to have it. So this is the basic understanding of the thing. So dimension modeling is the concept where you going to use, and this is given by Dr. Kimball said. Okay, Kimball is the guru for this. You have to make all this, all the master tables. Master tables means product master, you have account master, customer master. All the master tables will become a dimensional tables in this. And here we are going to have Dimensional tables, as you know already. So, but we have to dimension tables, and we have to know the other one is a fact table. So here we have to talk about different fact tables and different dimension tables, and what is a role-playing dimension, these and that dimension, what is many-to-many relationship, something we have to know about here. So whenever you load the data into the data warehousing, and after that, the story starts. When the data warehouse is created with the help of ETL, staging is done. The data, claim the data, staging is done. You're going to store the data into data warehousing, and here you may have Snowflake schema, star schema. Then with the help of SSAS, what we are going to use, we're going to create a cube, and we are going to create multi-dimensional analysis. Okay. So dimensional analysis. Now here we are going to write lots of, using a cube. We have to retrieve the data using MDX. Okay, MDX queries are there, so that you have to get, and this data you have to display in Ssrs applications. Okay, so now Ssrs is the reporting tool, so completely reporting, and where you should be able to get the data from the data warehousing applications, or data you can get from the cube also. So you have the multi-dimensional cube will be created where all the data from the data warehouse is given to the SSAS, and SSAS is going to analyze your data, and the data you have to take it from the cube. So, and you may create the reports, or you may take the data you're taking from the data warehouse and create a report, or data you can take it from OLTP applications also. That means what? If you have Oracle, you can get the data. You have SQL Server, you can get the data. You have some, say, Excel I have. So give me the data in Excel, I should be able to create a report. Or you may have data in third-party tools. For example, I have some data in .NET, or I have some data in. So OLTP application I'm talking about, these many. So you should be able to create the data .NET, or you may have a Java, or etc., etc. You may have SAP also. Now, Ssrs is not limited to only for the, you give me only the cube data, or you give me only the dimension tables and the fact tables, the data coming from data warehousing. So it is not like that. So Ssrs can take the data from the data warehouse, or it can get the data from the SSAS cube. So what SSAS cube is going to do, it is going to get the data from the data warehousing application. It is going to aggregate the data and keep the data ready. So slowly you would understand what is the cube is going to do, why we have to use a cube. Without a cube, what is going to happen? All of them we're going to discuss as we move. Okay, so, but SSAS is will create multi-dimensional aggregations and will keep the data there. So now if you wanted to create a report, you need the data. The data you may get from the data warehouse, or from the cube, or from any kind of OLTP systems which you're storing. So Oracle, SQL Server, Excel, .NET, Java, SAP, GIP. So end of the day, Ssrs is an independent module. So it can work with data warehousing, it can work with SAP also. So if you have the SAP drivers installed in your laptop, they directly connect to SAP database, probably Oracle database SAP is going to use, or you may have a DB2 database. You should be able to create lots of reports and give it to the end users. And how the Ssrs reports are going to be rendered, are going to be delivered to the end users. End of the day, you cannot create a report and keep it with you. The delivery channels are important. How Ssrs reports are delivered, you understand? So Ssrs reports can be deployed to the website of the company. This is by clicking of a wizard. So no coding here. Only you have to make sure some small configuration tool is there. Just click next, 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 finish. So you have to configure your Ssrs is your company's website. So what's going to happen? You create a report today, and from your laptop you use that wizard so that the report is displayed on the website of the company. So when, for example, your company name is accenture.com, or your company is some xyz.com, so www.xyz.com/reports. When you go there, all the reports are there. Just click on one report. People can see the report published by Pooja or published by Pascal. So this is by default, all the reports are available, web-enabled reports, just like Cognos. And today into SQL Server 2016, we can also deploy all the reports to mobile phones. So mobile reports are the new thing added. So this is also can be happen. So what is going to happen? You have to install one Android applications of that company. Okay. For example, I'm using say XYZ company. So XYZ company mobile application, Android application have to install. When you go to that mobile application, there are reports. Click on the reports. You should be able to get all the reports now in mobile. So this is what is the new in SQL Server 2016. This is new check. SQL Server 2016 got released very fresh. Okay, June 1st it got released, so 1 month back now. So we are in August 2nd, right? 1 month back only got released. So this is the new thing in Ssrs. Clear? So you should be able to create desktop reports and publish them into website, and you should be able to create a mobile reports and publish them into their own apps. Now, I don't want to use the reports like that. I wanted to have the reports to be delivered in your emails. So that is also possible. So email delivery is possible, and I wanted to have the reports to be delivered in wide variety of formats. I would like to have the reports in PDF, or I wanted to have the report in Excel sheet, or I can have an image format. I would like to have some image Excel, or I can have JPEG format, image format, PNG format, JPG formats. So lots of formats are available. Or I wanted to download in HTML format or HTML5 format. Lots of formats are there. So you should be able to deliver the reports. You should be able to deliver the reports via emails. And remember, for doing all of them, you need not know any technology. Very simple wizards are there. Anybody neatly, people who are failing in the 10th class also, they can take the documentation. They should be able to configure them. So it is not at all a complex activity creating a report. It's dead easy. So anybody, people who are from 10th class background, easily they should be able to do all these things without having any kind of a knowledge on Ssrs. Ssrs is pretty much tool, and anyhow you already know in ETL rules, but we have to understand lots of things, the differences between Informatica and SSIS. That anyhow slowly day by day we're going to see that. So now this is how the Ssrs is going to be used, and you should be able to achieve the reports and all. So are you clear? Are you with me? So any clarifications you wanted to have? Now, how is that the SQL Server MSBA started? So let us see the SQL Server and MSBA. Let me just show. Go back to the content and let me open this. Hope you're able to understand what I'm saying. Pooja, you're there? Okay, the term business intelligence introduced by analyst Dr. Howard Resner. And when you see this diagram here, and the SQL Server initially started by Microsoft in 1989, it was a purely RDBMS tool that time. Okay, now when you come down here till 2000, it is purely RDBMS tool. In 2005, Microsoft has added MSBA content, have SSIS and SSRS and AS got included here. And in SQL Server 2014, this is the latest version, but 1 month back you got one more. What is that? So SQL Server 2016 got released. I did not add it here. This is my mistake. So let me add this here. Okay. So copy and paste. And this is the latest version of SQL Server. But what is the new things here? It is released in June 1st, 2016. And here one beautiful point they have done it is big data concepts being added. Okay. So big data, I think people are saying about big data, right? Everywhere big data, big data. So SQL Server is having RDBMS and MSBA. You have lots of big data concepts. So let us understand what is the big data and all of them. So Now we are able to store the terabytes of data. That is where you have to store the data into data warehouse, and data warehouse is able to store the data in the form of dimension tables and fact tables. And this is what is happening. Okay, now if the data turned out to be more than terabytes, for example, now the people are talking about big data. So what do you mean by big data? Let us understand. Okay. So big data means when the data is more than, more than terabytes of data. For example, what is more than terabyte of data? I have a petabyte of data. I have eulabyte of data. I have exabyte of data. Okay. I have these kind of tetrabyte of data. So lots of data. When the data is more than terabytes of data, more than petabytes of data, more than this one, this kind of a data is known as a big data. Try to understand. So our data warehousing systems can handle, our BI applications can handle. So ETL and the Ssis is also ETL tool. These guys can understand and use when the data size is say 20 terabytes, say 30 terabytes or 100 terabytes of data, so no issue. But when you have a 2000 terabytes of data or 10,000 terabytes of data, think like that. When you have 1 lakh terabytes of data, when the data size is more and more, so petabyte of data, exabyte of data, hexabyte of data, eulabyte of data, this kind of a data is known as a big data. To analyze big data, these tools cannot work with you. Try to understand. These tools only can handle up to terabytes of data, but not, for example, if we have 10,000 terabytes of data, definitely these, data warehousing and SSIS and RS, ETL, SS, Informatica, everything is going to fail. So when you have this kind of a data, how can we analyze the data? This is where to analyze this kind of a data. Probably you're able to understand this. Analyze big data. Big data means you have to be very clear. This is the size of the data we're talking about, and the concept is known as a Hadoop. Okay, so Hadoop people are going to use. In the Hadoop, again, you have to store the data, and you should be able to again process the data. Okay, so Hadoop is also having lots of technologies. Now Hadoop is storing the data in HDFS, Hadoop file system. So there is no data warehouse here. So what is the limitations of any BA? BA, end of the day, it has to have the data in the data warehouse. Data warehouse means database, or it has to be there, the data in the Oracle or SQL Server, some OLTP applications. So any BA application, the limitation is they can they can analyze the data up to terabytes. That is the first limitation. Second limitation is, for example, we have SAP BA. Right, so we're talking about data warehouse, blah, blah, blah. So this one, have the BA applications, probably you have SAP BA, Oracle BA, SAS BA, or Cognos BA you have. All these things, they can process, they can handle the data up to terabytes, and end of the day, the data has to be there in the table. So you should be able to create a table or a cube. So cube means also one more table only. Then only you can process the data with the help of those, BA tools. That is the limitation of the BA. But now the data could be in anywhere. So the data need not be there in the databases. So here the default behavior, the default storing of data in Hadoop is that they should be able to store the data in HDFS, Hadoop file system. So here to process the data, here we are going to use MapReduce. Okay, MapReduce is the concept purely core Java based. Okay, this we don't need anyhow, but you have to be clear when to use what tool. If somebody is saying we are using Hadoop tool for analyzing data, and you say we are using Msbi tool or SAS BA tool to analyzing the data, so why they have to use that and why we are not able to use that? That is the question you may get in your mind. So end of the day, so this kind of a, big data has lots of concepts. You have Hive, you have MapReduce. The processing of the data, we have lots of new algorithms have been introduced. We have Hive, and you have a Pig, you have Yarn. Okay, you have Yan, lots of things are there. You have Uzi. Okay, so all of them have been implemented as part of SQL Server, SQL Server 2016. Lots of data science, big data concepts are known as data science market in this current world. So you will be called as no more ETL developer, you will be called as data scientist. Okay, lots of uh, data science that is called it. So you have a data you should be able to know first DBMS, RDBMS you have to know. Then you have to know about data warehousing concepts, right? And after the data warehousing concepts, people should know the ETL and everything. Data warehousing means you should know ETL. So ETL, when you know, you should be able to create data warehousing. Then you have to know what is the cubing and everything people are able to do. After cubing, we are having big data concepts here today. Okay, big data concepts means here you can implement different algorithms. For example, fraud detections, and you can have machine thinking, machine library algorithms. For example, the big data, Google Car is the best example for the machine library algorithms. Then you have arithmetical, artificial intelligence, AI. So lots of things have been added here, and these are the new algorithms for the data analysis in the current era. So this is where the data science is going on. So normal analysis you should be able to do, but today big data is giving you some more algorithms so that you can able to fraud detection. So M library will have machine thinking. So then you have lots of things are there. Okay? So these are called now data science. Now this is where Hadoop is going. Even this is where Microsoft SQL Server 2016 is also going with that. Are you clear? Now, so as we discussed, and SQL Server MSBA started in 2005, and as we see here, this is 2005 where MSBA started. Now SQL Server is not only RDBMS tool today. So RDBMS plus you have SSIS and RS and AS. That's what you have to be clear. So we have SQL Server integration, SQL Server, this one. So when you learn a single ETL tool, you know only the ETL, but you don't know what is the reporting and all. You have to work with some other team. Or you don't know how the data is getting processed, how the frauds are detected. That kind of algorithms are not known. But when you work with SSAS and all, you should be able to use many algorithms like machine library algorithms, artificial intelligence, then data mining algorithms. All of them will be part of SSAS. And you should be learning complete. So RDBMS you have to know, ETL you have to know, and data warehousing things you have to know. So lots of things you should be able to know and understand. So, okay, so already I think what is OLTP and what is OLAP and data warehouse. I discussed about this, right? So OLTP transfer online transaction data, it is analytical data, data warehousing. Read and write data, read-only data, live data, history data, small data, large data, normalized data, denormalized data. So more writing is there, so less indexes have to be there. So more reading is there, more indexes have to be there, and supports business, day-to-day business to improve the business. I wanted to take a decision, or I wanted to know how the things are happening in my company. This is the things you should be able to understand when we're talking about this. Are you clear? So is there anything I should be able to, I should tell? So now, how can we create these applications and all? So how is that we're going to use? Probably what is a data warehousing and all, right? So subject oriented and all of them, because you have worked with this. So subject oriented means blah blah blah. I think you might be aware of that. Otherwise also I'm going to take different data warehousing concept for 3-4 days later, so that you would understand in the better way. Okay. So then this is very, very important question. People would ask, what is OLTP and what is OLAP? So design for transactions, data modifications are frequent, not frequent, normalized tables, denormalized tables. Indexes are not recommended, but OLTP, OLAP, both applications are only purely RDBMS applications. OLTP means small data. OLAP means large data and historical data for analysis. Okay? So OLAP means data warehouse. That already I think, right? So more users and all of them. So why people have to use BI today? Because what is the BI means? It is a process to develop or improve a business by using the data intelligently. data, they should be able to use the data intelligently. That's it. So there is a saying I had read. Okay. So today the organizations are rich in data, poor in knowledge. Okay. So they're rich in data. So they have lots of data, but they are poor in knowledge. So what kind of a approach we have to take and how we have to use them, how we have to take a decisions, and this is what the people are now not at all happening. So this is where we have to use business intelligence applications, MSBA, SAP BA, SAS BA, and all of them, including Hadoop also. So these are called nowadays data science applications, and we have to work as a data science. So you have to be very clear on RDBMS also. So RDBMS, if you wanted to work with Hadoop, then you have to have core Java. Otherwise, you should know, the other technologies on. Already you had worked, so you will not be having any kind of an issue here. Okay. So it's a process. So BA is not a technology. So MSBA is a technology. So to develop, improve business by using data intelligently. So assess the health of the business, forecasting revenues and profits, quick decision making. So you will be having some kind of a trends and patterns are hidden as part of your data warehousing applications. Okay. So this is also one more new topic, that is data mining. So how the patterns are available in your this one. For example, people who are buying shoes, they're also buying a socks. That is a hidden pattern in the, but how much percent of the people who are buying a shoe, they're also buying a socks. So data mining algorithms can detect these kind of trends. Or how many people who are buying a toothpaste or buying a toothbrush, they're also buying a toothbrush and tongue cleaner and toothpaste. So this is some kind of a pattern. Associative pattern we used to call in data mine. So all these are some kind of a trends and patterns we have to understand. These we have to recommend to the end users, and this we have to show in the reports. Okay, so lots of things you should be able to do as part of your business intelligence applications today. Now SQL Server is having much more concepts, and Ssrs and Ssis and Ssis, and we should be able to do that. Clear? So now, as you know, when you go here, so this is the tool you have to install. So I'm going to give you the software for you in the Google Drive, and every day I'm going to record the sessions and I'm going to give it to you so that you can play them and say them. So this is the way we have to use SQL Server 2014 or 2012 we have to install, and SQL Server data tools for Visual Studio. This is where you have to create your MSB applications. So are you clear, Pooja? You're there? I'm not able to hear anybody. Are you there?
Hi Pooja, if you are on mute, you would have to unmute yourself and talk.
Yeah. So till now everything, like I understood everything, whatever I mean.
Good.
Yeah.
So do you have any questions to ask? Now, this is the tool we have to open. I don't know whether you have worked it or not. So open SQL Server data tools and go to file and the new project.
Yeah.
So here we have a reporting project, analysis project, and these are the projects we have to choose. And behind the scenes, .NET Framework 4.5 is working. And you have to choose Integration Services Project, and you have to give, say, Ssis demos, say for Pooja, right? So now I have to store this project in some D drive demos and click on OK. Okay, so you will have lots of things there. You have lots of tasks. So these are all we have to work one by one, and we have to understand what is the control flow, what is the data flow, what is parameters, event handlers, and connection managers, and this is how you have to add a new package here.
Yeah.
I click on this, you have to add a new package, and you can also rename the package if you wanted to have, say, demo number 1 and all. And when you go to the data flow, when you go to the data flow, here you have lots of transformations, okay? You have different sources we have. So we have CDC source, Excel source, flat file source. So lots of sources are there in this. And here these are the destinations we are having OLEDB destination, ODBC, flat file, Excel. And here these are the transformations, okay? Aggregate, condition split, data conversion, derived column, lookup, merge join, multicast, OLEDB, row count, split, and slowly changing dimensions, sort, union all. So other transformations you can find, audit, cache, CDC, lots of things are there. Clear? So these are the things we are going to work from tomorrow. So tomorrow I'm going to introduce the tool once again. I have to explain what is a control flow, what is a data flow, what is a parameter, what is handler. So all of them we have to go in the tool concept tomorrow.
Okay.
So are you clear?
Yeah.
Okay. So this is what is the demo. Hope you enjoyed the session and all.
Yeah, sure. I liked it.
Okay. Okay. So you can just give the feedback, and I'm going to start a new batch, from tomorrow. Okay.
Same
So,
time?
Same time. Is it fine for you?
Yeah, it works.
So Ssris is going to be started from tomorrow.
Okay.
So you can continue. Approximately it will take 2 to 3 weeks of time to complete Ssris.
Okay.
Minimum 3 weeks it will take, okay?
Okay.
And daily, 6 a.m. to, we're going to have up to 7:15. I'm not sure, at least 7:15 a.m. will be there daily from tomorrow, okay? So I'm going to give you all the recorded videos daily, and I'm going to give you all the practice work and interview questions and all I'm going to share so that you can use. And let me share something about myself. I started my career in year 2000, so almost 15 years back, 16 years back.
Okay.
So I worked for many companies like Accenture and Microsoft and IBM. Then I was also corporate faculty for Infosys Technologies for almost 3 to 4 years in Mysore campus in India. And currently, I'm not working as a full-time employee, but I do, take care of lots of architecting work, consulting work I do in the evenings. So lots of architecting and consulting work I do for the companies. So that is what is my profile.
Okay, and you have been working in data warehouse since the beginning, or it was like something else, and then you moved to data warehouse?
I started working with the C language in 2000, then C++, then .NET, then SQL Server, then Msbi and data warehousing. And Microsoft, we had a big project when I was in Microsoft. So there is a big database called FeedStore. Okay, this is purely a data warehouse database. We are loading the data from the Ssris, and we had a team in Singapore, we had a team in Dublin, we had a team in China. So big feed store data warehouse, and it is there, and Microsoft is using this database for the 5,000 applications. So this data, you have MSDN, you have all these things, right? All of them are coming from feed store database only.
Oh. And I'm sure the data warehouse must be very large in size.
Yeah, it is created not now. It is created 1982. It started the feed store database.
Okay.
Now they must be using now big data Hadoop now, because the normal data warehouse cannot handle this, right?
Yeah,
because
exactly.
Lots of things are there. So all completely commercial data, non-commercial data, all the data is getting into a feed store database of the Microsoft, which is there in Redmond now.
Okay.